Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video. All math-based, of course, and some PGA right behind me. In fact, Tiger Woods is about to tee off. It is 11:30 a.m. on a Friday morning, November 13th. Friday the 13th. I didn't realize that until right now. He tees off. I have no idea what's happening. Didn't look like he shanked it. Otherwise, he does his little... He throws his club. That looks fairway. All right, we're good. First shot on Friday morning. Tiger Woods teeing off, looking good. All right, I'm going to be doing some integrated math 1 material with you guys, specifically involving linear equations. I'm going to be looking mostly at point slope form. I'll do a little bit of slope-intercept form and converting into slope-intercept form. So I'm going to achieve 4 goals today. These are from a website called IXL, where I'm going to be doing some activities in IXL. For schools, I think it's free, all depending. Maybe the schools pay for it. I think if you sign up, you'd have to pay for it for IXL. They basically generate problems for you. They help build more difficult problems as you achieve better scores and such. I'll go through all that. What my goal in this video is to achieve a SmartScore of 100 on all of the different problems that I'm doing. Once you get a handle of the kind of problems they look like, I'll go a lot faster, so the video goes a lot faster. Anyway, I'll be doing 4 activities today. I'm going to start out a point slope form where I'm going to write an equation from a graph in point slope form. Then, given an equation in point slope form, I'm going to graph the equation. And IXL itself has a little graphing tool, but I'm going to draw a few on my own little screen as well, just to give you the idea of how you would do it on your own. And then the third thing, I'm going to write an equation in slope-intercept form from a graph. Y equals mx plus b. And the last thing and I'll show you different ways to do that. And the last thing I'm going to do is convert equations into slope-intercept form. I know that they begin by using point slope form converting into slope-intercept form. And I'm trying to think, I can use point slope form to convert to slope-intercept form for the other thing as well, writing an equation from a graph. So I'll do one way first there. Then I'll do the point slope form thing in that bit. And then in the end, they use standard form and we convert to slope-intercept form. I will not be graphing out of standard form or writing equations in standard form for this particular video here. All right, without further ado, guys, I'm going to get started. I'm going to go ahead and refresh my page, and it'll randomly generate a brand new problem for me. So right here, it's going to elapse time, and a SmartScore appears down below. Now, this just basically says the more problems I get right, the higher my SmartScore goes. I know I'm going to be botching that word a lot here. If I get something, it says right here, it's a dynamic measure of progress toward mastery rather than a percentage grade. It tracks your skill level as you tackle progressively more difficult questions, consistently answer questions correctly to reach excellence, or conquer the challenge to, it went away, conquer the challenge to achieve mastery. I want to show you that I can achieve mastery in these things and show you how it can be done with some work involved as necessary. So if someone's trying to follow along with me on these problems, keep in mind you would get randomly generated questions different than what I'd get. Now, I do want to also make mention that anytime you get a problem wrong, which I'll try and not do, I might make a mistake, but anytime you get a problem wrong, it'll lower the SmartScore, and it'll take a little longer to climb up thereafter as you keep trying to achieve that. Okay, guys, so I have a problem right here. Now, they do mention that wherever the red dot is where I have to... It's the point I have to use when typing in my equation here on IXL. So this red dot here is at the point 10, 20, 30, comma 90. That point's at 30, comma 90. And I'm going to just begin here by writing down information as needed, such as that point is 30, comma 90. Don't worry, I'm going to be doing a lot more when it comes to this point slope form, letting you know what the heck it is we have to do. But that's 30, comma 90 right there. I need to use that as my x1 and my y1. Why do I say x1 and y1? Well, because point slope form looks like this. Y minus y1 equals m times the quantity x minus x1. In point slope form, I just need to find the slope, and I need to find a point. So in this case, I found a point that's 30, comma 90. It's the one they, I guess, need to register for it to work. Now I need to find my slope. And unfortunately, because this one's a web browser, I can't really mark on it. So what I'm going to do is just follow my mouse here. To find my slope, I have a lot of different ways I can calculate it, but I can also kind of count it too. I'll show you what I mean. Here's a known point, 30, comma 90. If I keep tracking down until I find this point right here, 20, comma 40, that's another known point that is on this graph for sure. Another point for sure. Let me just write it down to make sure we have it. So another known point is 20, comma 40. I cannot call it my x1, y1, unfortunately, because I don't think that this website will register that for an answer. However, I go from 20 to 30. I'm doing a run from 20 to 30. I'm doing a rise from 40 to 90. So you can subtract these. You can do 90 minus 40 over 30 minus 20, and that'll show the change in y of 50, the change in run of 10, 5 over 10, or 50 over 10 becomes 5, 5 over 1, or 5. So my slope can be 5 in this equation. To show you on this graph, because this is how I'm more often going to do it, I'm going to say, here's my point here. I want to rise 10, 20, 30, 40, 50. That's the rise of 50 that you saw, and a run of 10. Here's what else I can do, and I haven't seen this change at all on IXL before. These are going up by 10s each, both on X and on Y. That means that for every 10 up I go up, for every 10 I go up one increment, I also go 10 over. And 10 over 10 is 1. My point is, I don't have to call this 10, 20, 30, 40, 50. I can just call it 1, 2, 3, 4, 5 as long as I call this a 1. So I can save time and just say how much I'm going up, 1, 2, 3, 4, 5, and over 1, because 5 over 1 is still 5. It's still equal increments when it comes to scaling and proportionality. When I compare X versus Y and my changes, they are both considered in that vein. That for every 50 I go up, I go 10 over, or for every 5 I go up, 1 I go over. Anyway, spending a lot of time on the first problem here, the point is here, no pun intended, the point is I can now write my equation because I have my x1 point, I'm going to substitute there, my y1 point, I'm going to substitute here, and my m value, I'm going to substitute here. So my final equation I'm going to type in on their webpage, I'll handwrite it first, is y minus y1 equals m times x minus x1 right there. That is an equation of this line in point slope form. That's a way that I can write the equation there. So when I write this here, now they automatically put these here. I think as you go higher up, you have to type it on your own, but I can put y minus 90 equals 5 times x minus 30. And I believe they always put the minuses in there. I'll show you when it gets a little weird and I don't really like it as much, but there we have it. Okay, now my SmartScore is 10. You'll see I will not be going up by 10 each time. I think the next time it'll only go up by 9. It's dynamic, as they said. It changes. All right, so now we have another one down here. That point is very low. That point is very low right there. Maybe I can just erase some parts of my bits here so I keep it kind of consistent. My x1, y1 this time will be something, and then another known point will be something here. Tell me something. All right. Well, maybe I don't do that each time. Anyway, regardless. So here we go. What do I got? I got a known point of, it looks like 70 for x and negative 100 for y. So again, my known point here is 70 for x and negative 100 for y. There's another known point I can find, but that's what I have to choose as my x1, y1. So another known point here, it looks like over here, I have a known point of 60, negative 60. 60, negative 60. Now you'll notice this time I'm not going to calculate slope. I will just count it, and that's what I'm going to do most of the time. But I will confirm the calculation afterward and to show you how counting it on a graph can still be fast. I need to find slope. So from this point, I'm going to go down. I'm going to fall 1, 2, 3, 4. That's a negative 4 for a fall. I'm going to run 1 to the right. That's a positive run. A fall of 4 is negative 4. A run to the right of 1 is a positive 1. My slope is negative 4 over 1, and that is negative 4. Now, if you're not convinced on calculating that, which eventually you will be. By the way, these went by 10s. They will not all go by 10s. Some will go by 1s. Some will go by hundreds, is what I've seen. I can use my points here again. I go from 60 to 70, so I do 70 minus 60. And I go from negative 60 to negative 100, so I'll do negative 100 minus negative 60. Now, this is another reason I want to show this calculation thing, so you're well aware of what you got to do. Negative 100 minus negative 60 has to happen. Subtracting a negative becomes addition, so I'm just going to save myself a little time, put it a plus. You're going to see where I'm going to use a plus in the equation as well in a moment. Negative 100 plus 60 is negative 40. I get a negative 40 here, and 70 minus 60 is 10. So I get negative 40 over 10, which does reduce to negative 4 over 1, or negative 4. So if you're convinced that the subtraction kind of will hold, because you can make a lot of mistakes here, switching numbers in the wrong spot, leaving out negatives, adding from a negative, a lot of things can happen here. I think the count will be a lot easier with that. Okay. So I do have my slope, I do have my x1, y1 here, and here's where I got to change some of these values. Here's where it's going to get interesting, especially with y. I'm doing y minus negative 100. Now, when I subtract a negative 100, that becomes a plus. I'm mentioning that now because we are going to have to graph out of point slope form later, and you want to know that a plus here means subtracting a negative. Now I have a -4 as slope, and I do have x minus 70 right there. So that is my point slope form here. Now I do, unfortunately, it looks like I do have to write a -100 right here because they leave this as a minus. But when they let me fill in the blanks on my own later, I do believe they'll let me put a plus on my own, and all will fare just fine. So I do minus -100 and a -4 and then a minus a positive 70, but here I am putting that plus 100. Anyway, let's check and see if that's good. Correct. So now you can see I can go a little bit faster here if I do recognize what I have. I just got to keep the form in mind, especially when I run out of ones where I get to fill in the blanks, like the blanks, and later I have to write the whole equation. Just make sure you know the equation, know what you're looking for, and you'll be set. So I do want to work a little bit faster here because a lot of the ones will kind of be the same. So I know I have a known point, x1 of 40, y1 of 40. So 40 will go here for y1. 40 will go here for x1. I need to find slope. I want to reduce that slope as well. As they say, write your answer using integers, proper, and improper fractions in simplest form. I always want to do improper fractions or integers personally. I'm not going to do any mixed numbers. Simplest form does mean reduced. So if you said up 10 over 20 to this known point right here, 10 over 20 isn't reduced. 1/2 is reduced. It's easier for me to just say up 1 over 2. My slope is 1/2. I don't think they'll let you use decimals, so 0.5 is out of the picture. I don't want to use 0.5 anyway, personally. I think I'm good from there. And, you can kind of mosey along from there. If you follow what I'm doing, these actually now go up by 1s here, so that count is actually the proper change in y and change in x, but the slope is still just the ratio reduced. So from here, I have the point 2, 8, x1, y1, 2, 8. I'm going to rise 1 and run 1, 2, 3, 4, 5 until I find my next point. So I have a slope of 1/5. So you can see how I'm going to get pretty fast in typing what I type here. Y minus 8, that's the y of 8, x minus 2, and a slope of 1/5. I'm bound to possibly make a mistake, like, oh, forgot to go negative. I don't know what it's going to be. This is a negative slope, for example. Something may happen. We'll see. But I do want to kind of go faster for the sake of time and everything else. I've already gone 10 minutes on this. I only have a smart score of 36. Come on, I need to get a smart score of 100. Let's keep going. -2, 2. That means I'm going to have an x plus 2, technically, in the equation. But here I'm just going to put a minus -2, because they don't really give me the chance to write anything else. And a y minus 2, because the 2 for y. My slope, my next known point, it looks like this is, to be sure, yeah, it looks like this is next known point. I'm going down 2 over 1. -2 over 1, or -2 is my slope. Look at all these 2's and -2's I have here. Subtracting 2, -2, subtracting -2. Boing. All good. Wonderful. We're all good here. All right. 70 for x, 40 for y. This keeps going this way. And I know some people are kind of confused on the point slope form in and of itself, especially when you practice y equals mx plus b. These really help when you're running across a y-intercept that's not necessarily an integer or a very easily identifiable item. For example, I don't know exactly where this thing is hitting. It's not hitting on 20, that's for sure. And I don't think it's even hitting on 15, halfway between. Maybe it's 17. I don't know. I'd have to actually do some conversion into slope-intercept form to figure it out. The point is, point-slope form, if you have another integer that you can obviously see, or if the y-intercept is way too far away, above or below, or you just can't identify what it is here, then use it. Point-slope form is really good for that, and you can still graph out of it as well, which we're going to do next. Anyway, the slope here, if you can't tell if it's crossing there, because I'm not certain, I'm sure it is, but I can go backwards as well and check out right there, and I can even start from here if I want. I can rise 1, run 3. That's a slope of 1/3. I hope you're following along pretty well here. It's starting to make sense to you and how fast I can go. I'm going to go super fast on this one. How about this? Up 1 over 4, 3, 4. So 4, 1/4, 3. Let's see if I did that right. There it is. You can rewind if you want to see what I did really fast there. Anyway, this continues. Eventually, I think this is going to turn into, like I said, me having to type the equation here. Give me one moment. Just got a text. Okay. All right. So let's see. 90, 40. 90, 40. X1 is 90. Y1 is 40. Remember, you are subtracting the positives. In the equation, there's subtraction. So when we pull out information, when we get equations like -90, we'll have to know that positive 90 is the x. Okay. Rise and run. Let's go down to here, up 3 over 1. They give you pretty easy ones. I mean, I hope they grow and challenge you a little more down the line. Obviously, I could make a mistake down the line, no pun intended. 70 for x, 80 for y. So here I have to write my own equation. See that? So hopefully I can kind of write it correctly the first time. Maybe I'll have to hand write some, but I'll kind of show you, like when I hit negatives, I'll kind of show you what I have to do in a handwritten form before I type it over. All right, so right here I have 70, 80. I go all the way down, I think, until I'm hitting that one. That one seems to hit. If not, it's definitely that one. That one's good. How much is the rise and run? 1, 2, 3, 4, 5, 6 over 1. I haven't seen one yet. Let me write down the information just so you have it. 70, 80. I believe was the x1, y1, and the slope is 6. So the point is that the slope is 6. What was I saying? I haven't seen one so far where you don't run or rise or fall 1. It looks like one of the portions of the fraction is always 1, which is strange here. I wonder how Tiger's doing back there, by the way. All right, so yeah, so there's the information. So when I type this thing, my y1 is 80, right? So I'm going to go y minus y1, so y minus 80. I don't think you need spaces. I'm going to leave the spaces out. Equals m, which is 6, times the quantity in parentheses, x minus x1, x minus 70, right there. That should be the equation. That's taken care of. Ah, well done. Negative slope, 80 for x, negative 10 for y. This time I'm going to do some handwriting here first before I transfer it over, so you know what I can type and how it accepts it. Because remember, they always put a minus in the thing, and I had to put minus negative. I want to actually put pluses where I can here. So let's get rid of this guy. We do have a known point that is, for the x1, y1, it is 80, negative 10. So that y1's a negative 10. My slope here, y'all, is, let's see. I got down 1, 2, 3, 4, 5, 6, 7 over 1. That's when it actually finally hits. So my slope is a negative 7 there. So my equation is going to say this in raw form. It'll say y minus y1, the negative 10, equals m times x minus x1. I only call it raw form because right now it's subtracting the negative. But you'll see when I type in this equation, I'm going to put a plus 10, and it should accept it, despite that template thing not being there. So I have y plus 10 this time equals negative 7 times the quantity x minus 80. Sorry, my microphone stand things in the way. That's, if you ever see me do this when I'm typing or looking at something, that's why. Something in the way there. Anyway, so that should be the final result, and it is. So now these are going up by 4, as you can tell. It looks like I'm going to be doing, I've done 10 questions so far. Not a lot, but you can see where, you know, I might speed up sometimes. Now both x and y are negative, so the opposite of those will appear as pluses in point slope form. You know what I'm going to do right now? I'm going to do this. I'm going to write y minus y equals m times x minus x, and then I'll just replace letters with numbers. You know, I can just double click here, hopefully. Yeah, and replace it. That sounds good. Some minuses will have to be pluses, though, so let me copy this just to get ready. All right, y minus negative 10 is y plus 10. M, what is that slope? I think it goes to the origin here, so up 1 over 6, because that's a 60. Negative 60. But that's a up 1 over 6. Boom. And then x plus 60, the minus negative 60 there. All right, I'm going for it, guys. Look, I got a little certificate. I don't know what it's for, but let's do it. All right, copy, paste, or paste. 30, 100. 30 for x, 100 for y. 30 for x, 100 for y. I have a slope of, from here, up 4 over 1. I think that's from here, up 4 over 1, so slope of 4. Can I work more quickly? See, these go by hundreds now. I don't know if that's part of the challenge, but they do. Both negatives as well, right? So I will be adding plus 100 on x, because of minus 100, plus 300 on y, because of the minus 300. And I'm going to rise, it looks like 500 and run 100, or rise 5, run 1. So my slope is 5. And at this point, if you do feel really good about this stuff, obviously, you can move on down to the next set of questions. I don't think I need to show any more scratch work, so I'll just show my face bigger because narcissism. Anyway, so here we go. I got I mean, if you need to know the formula, I'm going to kind of paste it right here each time, the y minus y1 thing. So both positives here. 300x, 700y. My slope looks like I can go up 1, 2, 3 over 1. So 300x, 1, 700y1, and then up 3 over 1. Okay, wonderful, wonderful. They eventually say, I think when you hit 90, they say, here's the challenge zone. I don't know what makes it more of a challenge unless they actually make the problems harder. I've kind of mentioned, they've always gone over 1 or up or down 1 each time. So maybe they'll go like up 2 over 3 next time and actually make it a little decent. 40 on x, 80 on y. I'm going to subtract 40 on x1, subtract 80 on y1. And my slope from down, oh, I can't tell. I think it's right here. Are we certain? That looks good, right? I'm going to guess. 1, 2, 3, 4, 5, 6, 7 over 1, slope of 7. Yeehaw. So hopefully with all this equation writing, you're feeling good about the idea that we can also graph from it too. If we can pull out the information from a graph to write an equation, hopefully we can pull out the information from an equation to write a graph. Okay. Now, with my students here, they're only required to get up to level 50 for full credit for something. After that, it's all extra credit for them. So hopefully they're feeling this out too, and they can kind of work that out. So I want to make sure they know how to do it. Sometimes it becomes a little bit of busy work. And with the amount of talking that I'm doing, you're like, I could have gone a lot faster. Or some people are like, how are you going so fast? It's just a matter, I'm counting now up 1 over 3 right there. Just know your formula. Have it written down. Have it written down like I have right here. Know your formula. Know what you're plugging in. Understand subtracting and negative becomes addition. Things like that. All right, what do we got? Gosh. Negative 500 for x, negative 800 for y. That's a plus 500 for x1, minus negative 500. And then plus an 800 there for y1, minus a negative 800. And then my slope, I'm doing negative now, down 1, 2, 3, 4, 5, 6 over 1. Down 6 over 1 is a negative 6 slope. Let's keep going. Plus 8 plus 4 for x1, y1, plus 8, plus 4. Slope is down 1 over, looks like 6, so negative 1/6. All right, almost in the challenge zone. All right, let's see. Let's do slope first. 1, 2, 3, 4, 5, 6, 7. So up 1/7 for my slope here. That's a y minus 2. M is 1/7, and then I have x minus, what is that, 1 right there. All right, now into the challenge zone, level 91. I've gotten one wrong. I feel pretty good about that. So I don't know. Okay, now the challenge does come in the form of the slope not necessarily being over 1 each time. You can tell it's not really hitting just over 1 on a run, which is nice. I wanted to get something actually different, write some more fractions out. So I'm glad they changed something. Sometimes it seems like they don't really change the challenge zone stuff. But plus 300 here for x, the x is negative 300, plus 700 here for the y being negative 700. And then my slope here, I got to find another point this is crossing through. Looks like right here. So I can go down 1, 2, 3, 4, 5, and over 1, 2, 3. That slope is negative 5/3. Good, a little bit of an actual little challenge there, you know? That's kind of what I'm looking for. This one's back to normal again, it looks like. Up 3 over 1 at x minus 50 and y plus 10. Okay, so y plus 10, up 3 over 1, x minus 50. You know, so it is a straight substitution, and with a graph, you are just counting your slope. If you're given the information of points, you'd have to calculate it like I did the first times there. I've already done that with my students, though, so this video isn't kind of for that. That's what I was saying. You could use it, but I really want you to rely on a graph when you have it. It's a really good measure to use, especially if the scales are the same on both x and y. Looks like this is a rise of 1 again, and we're running 7 because it goes to 70 on x, and we have 30 for y. So minus 30 for x, 1/7 for slope. I'm almost done here, sorry guys. And 70 for x, excuse me, I almost made a mistake. Yeah, this is one of the things, guys, you know, time-wise, I'm running 25 minutes for this stupid video. But I'm not calling it stupid, I'm just, oh, I am. For this one activity, it's kind of, maybe I shouldn't go all the way up to 100, but I am. Because that's what I do to myself. All right, minus 600, minus 700. Let's see, x minus, whoops, x minus 600, y minus 700. It's not 7,400. Weirdo. And then a slope of, no, right here. Up 1, 2, and over, I think, 7. So 2/7 slope. Just remember, reduce that fraction. That's why I'm counting just by those bits. That way I don't have to reduce anyway. All right. Can I just speed fast through these things after? You can pause and try it for yourself and then check for yourself as well. So I'm going to just kind of go faster because I do realize suddenly that this is going a lot longer than I ever thought it would. I didn't realize the smart scores would diminish so slowly after that. Like, I'm only going really by ones now, if you know what I mean. It's an up 4 there. All right, here we go. Actually, the hardest part is just typing. Like, I could handwrite this stuff faster, if you know what I mean. I'm trying to delete things and all that. Where do I go to? Here. So up 1, 2, 3, 4 over 5. I'm going to guess that was 4/5. I hope I got that one correct. See, if I get one wrong, it changes the smart score to like, it probably lowers back to like 85 or something like that. And that would be terrible. I wonder why a lot of my students don't want to keep going here for extra credit for those who already worked on it. They're like, it's taking too long. I'm like, if you get them all right, it won't. Well, actually, it kind of does take a while. That's not 1/1 right here. Where do I next hit another point? I guess right here. So I'm going up 1, 2, 3, 4, 5, and over 1, 2, 3, 4. So 5/4. Almost done, guys. Almost done. 3 more activities to go after this. Down 1, 2, over 1, 2, 3. So slope of -2/3. Let's get that one first, just out of the way. And then I have a plus 80 and a minus 70. Again, opposite of what it is. I think at this point, that goes left goes left unsaid. Plus 900, plus 900 for both, because they're at -900, -900. The slope is an easy one, up 5/1, 5. Okay, and congratulations, we are mastered. Okay. So that's the first one there, guys. That was point slope form, writing an equation from a graph. Now, I'm going to still use the same slope equation as I had before because we're going to transition over to graphing an equation out of point slope form. Okay, and I'll make sure to actually have a little graph here to show you the first couple times that I do it. And of course, time-wise for this video, you might want to consider, just kind of looking past and looking at the next thing. So let me load up the next set here. None of the stuff saves for me in my teacher thing. This is just me demonstrating it for myself, for students. None of that really saves like on record. It's not like, hey, I'm a master of it. All right, point slope form graph and equation. Here we go. So the next bit here, we're going to take something out of point slope form like this, and then we are going to actually draw its graph. So this is the opposite of what we were doing before, and that doesn't mean it shouldn't be taught, but it should make sense what I do on this. Let me zoom out a little. It should make sense what I'm doing on this as a result of what we last saw. But it helps to also write things down to pull out information the right way. So now that we're going to graph an equation here, I'm going to write down the equation for the first one and maybe some of the first couple and show you what I got, especially when information changes. But I got y-1 equals -3 times x minus 5. Okay, so the important bits here is it's better to pull out the information before you actually draw the graph, and then you can work from there. If I have y minus y1, this goes back to us writing the equation. If I'm subtracting y1 and if I'm subtracting 1, that means that y1 is 1. And I'll do the x1 next. If I'm subtracting x1 and if I'm subtracting 5, that means my x1 is 5. So I know that there's a point on my graph that this crosses through that is 5, 1. Not -5, -1, but 5, 1. The minus will say the point is opposite. After we've done, I forget how many problems it was, but after we've done so many problems on the other one, I really want to hit that home now. Because now people will sometimes question and go, well, wait, why? Well, there's a reason to why that has to go with the slope formula and stuff. I'm not going to really talk about that. But accept it after you've done so many problems writing the equations in that way, right? So now that we're doing the opposite here, that's what you want to accept as truth. Your slope is -3. I'm going to write it as -3/1 to just, bury the hatchet, understand that's the fall and the run to the right. So if I were to graph this just right here before even doing it actually on the other graph over there, I'd start at 5, 1 here, 1, 2, 3, 4, 5, and up 1. And then finding other points, I would go down 3 and right 1, and I could find other points there. Down 1, 2, 3, right 1. This is a lot like graphing out a slope-intercept form, only you're not graphing from the y-intercept necessarily, unless that's the point that they give you. And I can go up 3, left 1, by the way. I am graphing from just the point that I know. In slope-intercept form, you know that point is the y-intercept. In point-slope form, you know whatever point you were given as that point. So that's what I'm doing in this case here. So my line is going to look something like that. And of course, when I use this IXL thing, they can graph kind of for you. You click on a known point, and then you click on some other point that you want. So that's what my graph is going to kind of look like in the end here. If I go back to the browser here, I'm going to start at 5, 1 right there. And then see how I move this thing around. I can click on any other point from here. So I'll just go down 3, right 1, click, and that'll be the equivalent graph to what you're seeing over there on that side. And that should be the answer. Same thing here. I'm not going to kind of change any bits that I had here because most of this is the same right now, as in it's still a negative slope. I'm still subtracting a positive, subtracting a positive. So I'm going to start at 1 for x and 4 for y. I'm going to start at the point 1, 4. From here, I can do a fall of 5, 1, 2, 3, 4, 5, and a run of 1. If you have trouble with this without writing something down, please write something down. Absolutely. I am not going to discourage anyone from doing that. Absolutely do it. I'll show you just different bits. Okay, here's a different kind of problem, only because the x plus 3, even though everything else is kind of the same. So now that we have an x plus 3, let me just click the undo button a bunch of times till I go back to where I was. There we go. This is y minus 2 equals negative 4 times x plus 3. Now, x plus 3 is the same as x minus negative 3. I'm making mention of that because the form, the point slope form, has an x minus x1. We have to subtract the x1 value. And for this to show as addition, that would be because we're subtracting the negative. Therefore, our point that we are starting at is going to be negative 3 on x, but positive 2 on y still. It was a minus here. So kind of here on out, just for time's sake, I'm probably just going to say write the opposite. Write the opposite. There's a minus 2. It's at a positive 2. It's a plus 3. It's a negative 3. The slope is negative 4 over 1. And so on and so forth. I would start here, negative 3, 2, and I'm going to go down 4 over 1, find a point, down 4 over 1, find a point. But on IXL, of course, I can just do that straightforward from the tool they have. That's not using my line tool, but that's okay. All right, so let's go on to this guy over here. Let's go negative 3, positive 2. You can tell I'm kind of ruining my thought of doing the mastery just 100%. I can actually skip on to another level, but I want to cover all forms of this level before I move on, such as now we have a fraction slope. Now we have a plus and a plus in an equation in a formula that features a minus and a minus. X plus 2 is x minus negative 2. I'm going to go negative 2 on x. Y plus 6 is y minus negative 6. I'm going to go negative 6 on y. Negative 2, negative 6 is my starting point. My slope is 1/5. So I will rise 1, run 5. That's my first positive slope as well. Rise and run to the right will give you a positive slope. And that should be it. Give me 1 second. Okay, so from here I'm going to speed up until or unless I find different kinds of graphs. The only different kinds of graphs I can think of are if my slope is not an over 1 or 1 over. So I might be sitting here for a while, but the more that you see, the more you'll probably get a good feel of it. Because, you know, I've shown my students a couple times, and some get it, and, you know, some don't. And if you don't, sometimes it just takes re-exposure, trying it for yourself, kind of see what's going on there. So minus 1 is 1 over to the right, plus 2 is 2 down. That sounds backwards because it is backwards. And again, there's kind of a basis behind it. It's all about finding displacement. Sorry, that was a slope of 1/5. Ooh, here's a different kind of problem right here. So now, y plus 4 equals x plus 8. Where are my parentheses? What the heck happened to my overall formula? What's going on? Why don't I see my slope? Things like that. Well, let's write it in as point slopey form as I possibly can. Y plus 4 means y minus negative 4. Okay? X plus 8 means x minus negative 8. Now, if you don't see parentheses or a number on the outside, that must mean one thing. You're multiplying by 1. So if you multiply by 1, positive 1 specifically, see 1 times something is just that something. So my slope is 1 here. I'm going up 1 over 1. My point that I'm crossing through is negative 8 comma negative 4, and my slope is up 1 over 1. So I would be starting right here, and I'd be rise 1, run 1, rise 1, run 1, rise 1, run 1, rise 1, run 1, rise 1, run 1. Darn it. I wanted to try and do a 5 times fast tongue twister there. Rise 1, run 1, rise. I can't do that. I dropped my pen trying to do that. All right, so anyway, I'm going to start at -8, -4, and I will rise 1, run 1 right there. Boom. I will try and do that 5 times fast. You try and do this 5 times fast. I try and say rise 1, run 1 5 times fast. All right, +7 is a -7. Sound weird, don't it? -4 is a +4. It's opposite. Just like the form that we entered, it's opposite. Down 1 over 2, down 1 over 2, slope. This is one of those things where I'll probably try and go a little faster until I run into something like this. So now you're like, okay, well, what do you do here? And again, it does help to write things down in case you're stuck on what there is. One interesting feature of this that I'm going to mention also here is that it's really close, and so was the other one. It's really close to writing this almost in slope-intercept form. And we'll talk about converting to slope-intercept form from point-slope form when I hit the 4th activity after like an hour of video that I'm going to be doing here. So right here is a y plus 5. Again, that'll be y minus -5. We'll just remember that. Okay, now there is something that's multiplying with x. Now inside the formula, nothing actually does multiply with x, inside the parentheses. But outside of it, the slope would. That must mean that slope is probably a 2. But how is 2 only multiplying with x and not a parenthetical set of x plus something or x minus something? Well, that would only be the case is if in parentheses 0 was being added or subtracted from x. And I'm just going to put -0 because the formula has a minus. So subtracting 0 means my x1 value here is indeed 0. I'm hitting a 0 on x, and I'm hitting, remember, +5 is a negative, minus -5. So -5 on y here. My slope is 2. It's 2 over 1. This goes back to the thing I was talking about that's kind of interesting about writing this in slope-intercept form if you wanted to. I am starting on the y-intercept, on the y-axis right here. And then I do my rise 2, run 1. It's like slope-intercept form. If you look at the equation, y plus 5 equals 2x. Hold on. Y plus 5 equals 2x. If I subtract 5 from both sides, I get y equals 2x minus 5. Hey, there is slope-intercept form. One of the easier conversions because I didn't have to distribute first, especially with a fraction. But nevertheless, that is point-slope form. Excuse me, slope-intercept form. And my point-slope form brought me to the same point, literally. Now, I'm sure we're going to run into one where there's no y. It'll just say y equals right there. So you'll understand on those ones that would mean a y minus 0 in the same way as this one was a x minus 0. X minus 0 is a little trickier to look at because the parentheses went away. So, well, it all depends. Okay, so where am I starting at? 0, -5, and I will rise to run 1 like so. That should satisfy it. Okay, so perfect example. This is where it says this y equals right here. Now, here is an example where I still want to treat this as point-slope form. I'll show you the equivalent of slope-intercept form where you're like, yeah, you can't even do that on this graph, much less on any graph would you want to. So let me first write out, I'll start off point-slope form, just so we're there. Y equals means y minus 0 equals. That means the y1 value is 0. -2/5 slope. X plus 8 means x minus -8. So I will be starting at -8 for x and 0 for y. Slope is -2/5. So -8 for x, 0 for y, slope of 2/5. Let's just do it straight on the graph right here. Boom. Down 2, right 5. Like that. And that would be the graph. Now, before I proceed, I want to show something. Two things. One in this graph and then one in the equation. Notice that the y-intercept here is not an integer. It's not. It's just not. Therefore, slope-intercept form would not have been very helpful even out of something that's not in IXL if I do it by hand, because I don't want to start from a fraction y-intercept and then continue on the slope in that direction. Heck no. So the original equation, guys, if I wanted to convert it in slope-intercept form, the original equation says y equals -2/5 times the quantity, x plus 8. And listen, it is very possible that when we do the challenge mode of converting from point slope form to slope-intercept form, that maybe they give us these fraction things. We'll see. But we won't have to graph them. Now here, I distribute, multiply, to put in slope-intercept form, y equals mx plus b. I need no parentheses, y by itself, the x term first. My y equals mx plus b is y equals -2/5 x, not a problem. This is minus, because the negative times positive, 2 times 8 is 16. 16/5. See, 16 can't divide by 5. -16/5 is -3 1/5. I'm going to leave it like this. That's negative 3 in the fifth. Who wants to graph out of that? Not I. No, I do not want to graph out of that. So you can tell point slope form had an advantage in this problem. Probably in some of the other ones. I haven't been looking at converting a slope-intercept form yet. Just this one was like, it's so fast you just have to distribute. But I really wanted to hit that one home, that the y-intercept there, if it's a fraction, makes point slope form more appealing when you have another known point that you can cross through. All right, gets a little weird here as well. So I'll keep writing as long as they're weird. If they're not weird, I won't. So this one is weird in what way? Well, that negative x, right? So I have y minus 7. This is why writing this down helps. Remember when it was a 2x? That meant that slope was 2, and in the parentheses was an x minus 0. Here, it's a negative x. That means inside is an x minus 0, and multiplying on the outside is indeed a negative 1. See, x minus 0 is x, and negative 1 times x is negative x. So x minus 0 and a negative 1 slope. So can we pull out the information? Point of 0, comma 7, and down 1, right 1. You guys agree with that? I think I do. You could add the 7 over, put it in slope-intercept form. You'd start at 7, go down 1 over 1, things like that. But still, pulling out the point slope form is still pretty nice in that vein. All right, this one is, by and large, more basic. However, this is the first time, I think, that we're seeing a slope that is not just over 1 or down 1 or anything. We're going down 5 over 6. I don't remember if that's true or not. No, I take it back. We've already done that. I forget what I said. The point is 2, comma 2. Remember minuses? 2, comma 2. Down 5. Right 6. Boom. There's my graph. See a fraction y-intercept. No good. No good. All right, guys. This is going to go kind of the same way each time here. So I'm just going to speed up a little bit, see if I run into anything a little more particularly fancy. And hopefully you run into, hopefully you start to understand what I'm saying here when I talk out loud. So now a 1 would have been outside of this, multiplying by the quantity x minus 6. So 6 for x, negative 3 for y, and my slope is a positive 1, up 1 over 1. You can pause and rewind that when I said 6 for x, negative 3 for y, or you can hear me say it again. Obviously, these aren't very prepared. This is a lot like the y minus 0, right? Y minus 0. So I'm at 6 for x1, 0 for y1, 6 comma 0. And I'm going to rise 3, run 4. So far, I don't think anything's really hitting differently. I mean, we hit the different things already. It's hard to do anything different on these other than give you fractions or have them go by tens or something like that, which I don't know if they'll do that. x1 is negative 4, y1 is positive 1. You know, people will be tripped up just by looking at this. That's why writing it down is important. You might start seeing this as positive 1, negative 4, by accident, like just doing the opposite. We got to go negative 4 on x, positive 1 on y, go down 2, right 3. So again, writing it down will help. As I say it out loud, maybe you can also write it down when you see these. Negative 5x, negative 5y. Boom. Slope is up 5 over 7. Up 5 over 7. See how fast I can get through to the challenge mode here. Yeah, nothing's changing, y'all. I'm 43 minutes into this thing. Pretty not happy about my choice to go up to mastery. I hope those who watch it are making sense of what's going on, though. Okay. Like I said, I'm going to just kind of keep moseying along. If I feel like there's nothing different in the challenge mode, I don't know. Knowing me, I'll just go through it still. So here's the challenge mode. So, okay, see, now they're going by tens. I mean, does that change much? Not really. 30, comma, negative 10. Now going down, see, I like that here they give you a slope of negative 4, and I need you to understand that I can go down 10, 20, 30, 40, and over to the right 10. That's still down 4 over 1 like we did in the last set of problems. Down 10 over 40 is down 4 over 1 when it comes to ratio. Change in y over change in x rate. It's a constant right there. So that one should work there. 30, negative 10. Okay, good. This one was not like that. Slope of negative 1, but I start at negative 4, comma, positive 7. Slope of negative 1 right there. Just let's keep moving. Haven't got anything wrong yet. Go by 200s. Negative 200 on x, negative 600 on y because of the pluses. Up 2 over 1 is the same as up 200 over 100. That should be fine. Hopefully they don't trick me up and say x's are going by 1s and y's are going by 10s or something like that. Hey, negative 10 thirds. They're making me do a lot here. So right 4 up 2, got to go down 10, which is to negative 8, and right 3, like that. You can't fool me. Y minus 0, so I'm going to start at negative 600 because the plus, comma 0. Boom. Up 9 over 4, up 900 over 400, equivalent. And yeah, so there's really nothing else I can do that's different from here, so I'm just going to continue and finish. Hopefully you're feeling the same as far as, hey, I can get extra credit if I'm Mr. Robinson's student, and I'm really understanding this. I do want you to know how to hand draw it as well. I mean, clicking this is the equivalent of hand draw, only you're doing a single point and not a bunch. You know what I'll do on one of these? I don't know if I can do it on this one. I probably can't because I probably can't fall 10. I'll show you what I'm going to talk about in a second. Like, I wanted, instead of going up right, maybe I'll go down left. You know, I was just going to talk about that. Or instead of down right, I'll go up left. But I can't go down 10 here. I can't fit that. I can go up 10 and right 7. I think that's it. I'm going to trust it. There it is. Probably 2 more problems. Negative 10, negative 30. And instead of down 2, right 1, I'm going to go up 2, left 1. It's the same line. Just that if you're going to draw graphs, you need to know I can go down right and up left, and I'll get the same thing. Okay, one more problem here. Positive 4, negative 2, up 5, over 2. Boom, and we are masters. All right, I hope you felt pretty good on that one there. And I'm going to move on here. Yeah, I'm just going to do this all in one video. You can, it's your responsibility to check the timestamps for what you want to see, and you can move on, obviously, when you're looking at it. But I'm going to go to slope-intercept form now, write an equation from a graph. Do I go all the way up to level 100? Maybe, because maybe they start hitting fraction ones, and just how do you calculate fractions out of them? I'm going to do this only in one particular way, which is only using y equals mx plus b. The only reason I'm stating that is because the next thing I do is I'll be converting into slope-intercept form from point-slope form. Maybe I'll do the several last in point-slope form. We'll see. But I'm doing it from a graph. Now, I did them with my students from information, but that also means I can pull information from the graph, which is really the key here. Sometimes they'll give you the y-intercept, and hopefully sometimes they don't give you the y-intercept, and you'll probably be able to look at the graphs and tell, all right, when there's a graph, what the y-intercept is, and you can do that. But if it's a fraction, maybe you got to compute it from different points, which I'm looking forward to doing and working with you on. Anyway, I'm going to be converting from point-slope form to slope-intercept form, in the last thing that I do is converting into y equals. I'll also be doing from standard form, slope-intercept form on that. All right, slope-intercept form, write an equation from a graph. Let's go ahead and take a look at what those look like here. The first one. So you can see in there, they give you the y-intercept in essence. The y-intercept is the negative 4, and then you've got to find the slope. In slope-intercept form, which is y equals mx plus b, you will be determining m and b. All right, so slope-intercept form looks like, once again, y equals mx plus b. The b is the y-intercept, and the m is the slope, as m was slope in point-slope form. So the b being the y-intercept here, b is negative 4. The slope we still got to find. You take another known point here. So 0, negative 4 is a point I should use, and I should use any other point around it, like that one, or this one. I'll go ahead and use this one. From negative 4, I go down 3 and right 1. So my slope is negative 3 over 1, which is negative 3. So my equation will be y equals negative 3x minus 4, like that. Y equals negative 3x minus 4. So yeah, that's how I'm going to be doing the majority of these. I mean, that's kind of how it shows up. And we'll kind of see what different graphs we get here. But that's the key. SmartScore 10. My y-intercept here, like I said, I'm not probably going to write down a lot unless it gets actually different, uniquely different, because now we've seen a few of these as far as what we do. I'm going to be rising 1 and running 1, 2, 3, 4. So my slope is 1/4, and I have a y-intercept of negative 3. So that's y equals 1/4 x minus 3. And yeah, you know, I can put, you know, this isn't 1 over 4x. It's doing order of operations. So it actually computes the 1/4 first, and then it's multiplying that whole fraction by x. So this is fine to write. I wish they'd let us do the over fraction as opposed to just the forward slash, but it doesn't look like they're going to let us here. All right, this is a y-intercept of negative 10, because now these go by 10s right here. So my b is minus 10. When I do my slope again, though, just like before, I can reduce my fraction. So even if you say up 10, let's see, up 10, 20, 30, 40, and over 10, 40 divided by 10 is 4, just like up 1, 2, 3, 4, over 1 is 4. So I'm going to have y equals 4x minus 10. I'm going to do the copy paste thing as I did before. Put y equals mx plus b. I don't know if that actually makes that easier or harder, that they're not actual numbers when I do that. Okay, so 60 up 2 over 1. Y-intercept of 60, and I'm going up 2 over 1, so 2. All right. Doesn't matter that it's only in the first quadrant. You can still kind of recognize that it's there as you mosey. We got a negative slope this time, which is pretty nice, and I want to show you kind of going backwards what we can do as well, in case you're not sure. Y equals mx plus b here. My y-intercept is a -9, plus -9 is -9 here. My slope, if you couldn't tell because the arrow's in the way, maybe you couldn't tell it's down 1 and right 2. That's okay. We can go up 1 and left 2 to find that point as well. And up and left is still a negative slope, so I'm still getting -1/2 when I do that there. Y equals -1/2 x minus 9. Let's keep it up. Like I said, these go kind of fast at that point when you use the graph. If you want to pull out information to write, I think eventually I will be doing that. I want to see if they start hitting things where the y-intercept isn't so obvious, though, and we got to calculate. If they don't do that, kind of boo-hiss on their end. I really wish they did a couple of those, but if you weren't given a graph and you were given equations, I think I got to do a couple of those. I'm going to wait till I hit the mastery level, though, and see if it actually gives me those. And if it doesn't, I'll do it on my own manually. I just don't want to do it for every single problem. If you have a graph, you should use it. I mean, that's a pretty big should. You really should. Minus 50 here for y-intercept. From the y-intercept, I can rise 1, 2, 3, 4, 5, and run 1. So that is a slope of positive 5 there. All right, give me something else. Come on. That's something else. So the y-intercept, I guess, is -10. There's no other way, because this is the only other known point besides that. They wouldn't give us something unless that wasn't it. So y-intercept of -10. And from there, I'm rising 1 and running, it looks like 6 to go to my other point here. So that's a slope of 1/6, like that. -50 y-intercept, rising 1, running 5. Didn't we have one like this already? No, it was 5 slope. 1 over 5, and I'm missing Tiger Woods, guys. And y-intercept of -50. Excellent, yes. I don't know if these are harder or anything like that, so I don't know why they just throw you in for a loop. You do some word problems where you start in you only look at first quadrant, so I guess it's realistic to do this. Rise 1, run 7. Make sure you put that x in, by the way. I know, some people seem to miss out on that. I don't know why. It's so important in what you're doing there. Okay, I'm going to change this one up just a little bit as far as what I'm going to do with it, because we haven't been looking at this in different ways. Let's say I couldn't tell that was hitting at -100. Let's say I could not tell that was hitting at -100, but what I could tell, maybe, is 2 other specific points that it did cross through, because, maybe the arrow is kind of like, is it really hitting -100? Because who knows, maybe it's not. So let's say I knew this point here, 10, -80. Let's say I knew the point 10, -80. This is for the crowd if you don't have a graph or you don't want to use your graph. And let's say that I knew another point here. Let's say I knew the point 60, 20. 60, 20 here. All right. Let's write the equation in y equals mx plus b form. Now, ignore the graph completely right here if you can. I'm not even going to count rise and run with it. To find the slope, I'm going to have to do y2 minus y1 over x2 minus x1. 20 minus -80 over 60 minus 10. 20 minus -80 is 20 plus 80. That is 100. 60 minus 10 is 50. 100 over 50 is 2. That's my slope. Right now, my equation should now look like y equals 2x plus b. I still need the y-intercept. How do I get my y-intercept without a graph? You have an xy right here that you can plug in this solution for, 60 and 20, or this solution for 10 and -80. I'm not going to do both, but I'm going to tell you right now, it doesn't matter which one you choose. You should still get the same answer. I'm going to go ahead and choose the 60 and 20. So for 20 for y, I'm going to have an equation that says 20 equals There's my 2 slope. Here's my 6e for x and plus b. I'm going to solve for b. 20 equals 120 plus b. And if I subtract 120 from both sides, 20 minus 120 is negative 100. So b equals negative 100. Therefore, my equation is y equals 2x plus negative 100, or y equals 2x minus 100. So 2x minus 100. That was done completely without actually using the graph. I had 2 points. I needed m, I needed b. And that's how you do it. You substitute m, a known xy point, could have been either of these, either 60, 20 or 10, negative 80. Find the b, rewrite the equation. There it is. I've done that stuff with my students before. I was thinking maybe they could run into some like that where the y-intercept isn't so obvious. That's when I'll have to do it again. I won't be doing it again until then. Let's confirm that that works with our graph, though. It does look like it's hitting negative 100 as a slope, or as a y-intercept, excuse me, and the slope is up 2 over 1. Faster, right? A lot faster there. All right, so no fraction y-intercepts just yet still. I don't know if we're going to hit them, I'll be honest. I don't know. And if we don't, I think at some point, I might move on to mastery or something. I keep saying I would. I think this time I actually would. Y-intercept of negative 3, slope of down 1 over 1, slope of negative 1. So I could write y equals negative 1x minus 3. You know what else I could write? Because you might have to transfer from one to the other. I can write y equals negative x minus 3. Remember, when there's not a 1 written in front, that means that that value is a 1. It's a negative 1 in this case, but negative x minus 3 should hold water, just like everything else. Just be, careful about that. Y equals x plus 8, or minus 8, excuse me, because that's a positive 1 slope. Up 1 over 1, positive 1 slope. And you can see where that kind of jumps into play. So slope-intercept form, all good and dandy here. This is not a slope of negative 1. It looks like it, but you can tell it kind of slaloms off a little bit right there. And I have to go down this far. Down 1, 2, 3, 4, over 1, 2, 3, 4, 5. Negative 4/5 is my slope. Y equals negative 4/5 x minus 2. Do not forget that x. It'll mark it wrong, because that's not right. X needs to affect y. Anytime you hit a different x, you're going to hit a different y as a result. It depends on y depends on x. 1x plus 7. So y equals x plus 7 works there. Okay. X plus 80. I'm assuming they're going by tens. Yep. Okay, can you give me something different? All right, I'm going to move on to... Oh, I can't jump a level, apparently. That's interesting. I thought I could. Teacher results not recorded. Boo-hiss. I used to be able to just jump a level and say, hey, let's just go to mastery. Maybe this is the last bit of level. Negative 20, slope of 1. See, all these slopes of 1, guys, they're not as fun anymore. For you, if you're doing them, sure. X minus 20. Yeah, I don't think they're going to hit fraction y-intercepts. I thought that it would be neat and useful to look at. But alas, it wasn't meant to be. Maybe I'll do one other problem with the math, though, and show you how you go from point-slope form to slope-intercept form, given what we know. Depends on what we hit. Okay, negative 10 and go down 1, 2, 3. So, over 1. So, y equals negative 3x minus 10. Okay. 1x plus 30. And 1x minus 3. Sorry about this. Hopefully you're feeling pretty good about it. Again, I'm using the graph. Come on, this is not challenge mode. Negative down 2 over 1, 2, 3. Y-intercept of 1. So y equals negative 2 thirds x plus 1. The challenge is me typing in the right keystrokes. Apparently. Oh, they go the hundreds. Oh, that's tricky. Y equals up 1 over 1, so x minus 600. I mean, I came this far. Why don't I just finish, right? Oh, that goes kind of high. So 1, 2, 3, 4, 80 over 1 over 10. So up 8 over 1. Slope is 8. Y equals 8x plus 20. 1x minus 4. I kind of personally wish that IXL would change their challenge algorithm and the kinds of problems that can be drawn. It would be nice if we were getting something with a y-intercept fraction because we'd have to calculate. I feel like they want you to rely on the graph solely if you have a graph, which is something I'd want my students to do as well, unless the graph throws in a shakeup. And that's what I'd love for them to kind of give you that wrinkle of. There's another thing they have for arithmetic sequences that I hate, that they don't let you write equations for things with a common difference that's not 1 if it has a starting value that's not at 0. It's weird. I'm not going to talk about that. I just don't like that. I think that was up 5/4. This might be my one mistake because I was talking during that time. So I think it's that. Knock on wood. Yes. 2 more. 1x plus 6. And let's see how this last one turns out. And x plus 800. Okay. Not very fun. So what I'm going to do now, I got one more set that I'm going to do, and it's converting from point slope form to slope-intercept form and converting from standard form to slope-intercept form. So I'm going to use a lot more of the whiteboard this time and a lot less of any graphs. In fact, I don't think they give you graphs. I could confirm that a graph is equivalent to one of the equations that I have, but I'm an hour into this thing so far. I'd really love to finish. I think you'd love for me to finish as well, as you're learning this practice. So my last one is just going to be about solving for y. Okay, about solving for y. So here's the example where we're going from point slope form to slope intercept form. I'll zoom in on these, I think, because I kind of need you to be able to see it. All right, and from here, I'll write the equation each time. We'll be getting the answer. Each one is going into slope-intercept form, just so you know. We're not going to go into point slope form or standard form. We're going to go into y equals mx plus b. Now, what's the difference between y minus y1 equals m times x minus x1, besides everything, and slope-intercept form here, is that this one has parentheses, this one does not. This one has something with y, perhaps, unless it's minus 0. This one does not. So this one is y by itself and simplified. So we have to get y by itself and we have to simplify. So on this first problem right here, I have y minus 7 equals 1/3 times the quantity x minus 3. I must distribute the 1/3 into the x and the negative 3. And 1/3 times negative 3 is just negative 1. So I'm going to get y minus 7 equals 1/3 x minus 1. To get y by itself now, I'm just going to have to add 7 to both sides here, plus 7, and add it to the constant. And now we're going to get y equals, here's my mx plus b, y equals 1/3 x plus 6. There you go. That's my slope-intercept form equivalent of this thing that was in point slope form. These both represent the same line when graphed. Not that I'm graphing here, but that's, if I graphed one versus the other, they'd fall exactly on the same line with each other. Plus 6. I can't see my SmartScore if I'm too zoomed in. There we go. A little better. All right. At some point I'll kind of do them mentally. Like I'll say them out loud, and I'll say, yeah, if you follow along, that would kind of make sense. Until we run into some new kind of wrinkle. I don't know if we will. I think once it hits past level 68, literally the SmartScore of 68, you will be looking at standard form equations then, and that's when you can do a little bit more. All right, what I really hope we get some y-intercept fractions at some point so we can practice that distribution, because this gets pretty basic otherwise, all told, even for the students. 1/4 x minus 4, once again, is 1/4, no parentheses, 1/4 x minus 1. A fourth of negative 4 is negative 1. So I got y plus 6 equals 1/4 x minus 1. Subtract 6 from both sides, and we get y equals 1/4 x minus 7. So that's going to be my equation here. So again, if I keep writing it, guys, I'll be here all day. That's why it's extra credit for my students. Y equals 1/4 x minus 7. I mean, they just need to practice it. I just want to make sure they can do it. They get up to a SmartScore 50. Good, they did about 8 or so problems correct. Okay, this one has no fractions, for better or worse. I guess it's for better for most people here. I got y plus 10. Let's see if we can do 2 steps in one. Negative 3 times x plus 10. I'm going to distribute, but at the same time, guys, I'm going to subtract 10 from both sides. There will be a minus 10 on top of what we do here. So let's see if you can follow along with this. I got y equals, and this would become negative 3x minus 30. Negative 3 times 10 is negative 30, minus 30. Negative 30 minus 10 is negative 40. So that'll be negative 3x minus 40, just like that. All right, so that's doing 2 steps in one. Probably not very safe, especially when negatives are involved, but just kind of try to make it happen, just being equals. All right. Oh, I did something wrong. See, that's why we don't do that. What did I do wrong? Oh. 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 That minus was for the 3x. I didn't put the equal sign. See, I made a mistake. Sorry, I didn't put... The first time I didn't put the equal sign. I guess I just went straight to minus. And I said that shouldn't be a minus. That should be an equals. No, the minus 3x was there. My first incorrect problem. Boo hiss, it happens. I was like, there's a typo here. My answer here is correct. I just erased the minus that was the minus that needed to be needed there for the equals that also needed to be there. All right, let's see if we can do this kind of in our head here. Until something changes, I'm going to be doing this in my head. 3x plus 9 in distribution. Subtract 6 from 9, you get 3. So this is y equals 3x plus 3. Kind of weird how it shows the x plus 3 inside there with a 3, and then it actually still becomes 3x plus 3. 1/6 of 6 is 1. See, I don't think they're going to be changing that very much, the number of that. I really wish they did. I wish we could play with a lot more things. Again, IXL, not the best thing about that. So y minus 5 equals 1/6 x plus 1. Add 5 to both sides, it'll be plus 6. So y equals 1/6 x plus 6. Kind of mental work there. Okay, let's not mess this one up this time. Negative 9x minus 45. Subtract 9 from negative 45, you get negative 54. So y equals negative. There we go. 9x, yeah, that felt awkward to type. I guess I definitely didn't type that last time. Negative 7x plus 56. Subtract 9 from 56, I get 47. So y equals... See, that's not a very fun one to graph. Negative 7x plus 47. It's not fun to graph if you don't have that y-intercept, right? That's really high up. All right, so this one's just a negative 1 on the outside. Distribute the negative, I get negative x minus 6. Subtract 7 from negative 6, you get a negative 13. So y equals negative x minus 13. Pretty soon we're going to get in standard form, guys, so I feel like there's nothing really heavy going on here. Negative 7x plus 63. Negative times negative is a positive. 63 plus 9 is 72, so y equals negative 7x plus 72. 1/7 of 7 is 1, so 1/7 x plus 1. Add 6 to the 1, you get 7. So y equals 1/7 x plus 7. Sorry, guys, it's just that, you know, these problems don't actually end up getting varied from, hey, 1/9 of 9 is 1. 1/9 x minus 1. Subtract 9 from negative 1, you get negative 10. Y equals 1/9 x minus 10. This is, honestly, this is probably the worst video on my YouTube channel. I prepped for it in terms of I'm ready to do all these problems. I did not. Hey, here's a different one. Finally, thank you. But it's probably the last point slope form we get to do before they go to standard form. At least 1/3 of that number isn't just 1. Not much harder, but at least it's different. I'm going to actually do a different problem here. In fact, I'll even show the distribution step just because this is the last problem here I'm going to have to do with this accord. I might have to do a few more steps. I might have to show the steps in standard form a little bit more than I will in point slope form anyway. Anyway, when I distribute here, that'll be 1/3 x plus 1/3 times negative 6. That's just, you know, that's the distribution step. 1/3 of negative 6. Negative 6 divided by 3 is negative 2. Negative 2 times 1 is negative 2. So that'll be a negative 2 here. So y plus 7 equals 1/3 x minus 2. Finally, it's down to minus 1. Pretty close. Subtract 7 from both sides. Y equals 1/3 x minus 9. All right, 1/3 x minus 9. My throat's getting scratchy. Make sure it wasn't a negative 1/3. It was not. Minus 9, and we're good. All right, now we have standard form here, guys. So this is where I'm going to be writing a little bit more. Doing a little bit more handwriting with y'all. Negative 5x minus 20 equals negative 6y. I guess that's not really standard form, is it? Excuse me. I thought all these were in standard form. I think I was wrong. Standard form would look like ax plus by equals c, meaning the x and y terms would be on the same side of the equation. This is clearly not. In standard form, generally, a, b, and c would be whole numbers, like these ones are, and the x term, the leading term, would also always be positive. So maybe it's not exactly standard form, but oh well, close enough. You got to get y by itself, though. That's still the end goal. All y is being affected by is a negative 6 that's multiplying by it. So if I divide everything by negative 6, good, I get problems with fractions. That sounds weird. It's just that good, we have some challenge here. Divide by negative 6. I'm going to go ahead and write y equals on the left side. I hope you're okay with that. The y, I'm just moving it over here. Y equals. This stuff I'm going to move over here. Negative divided by negative is a positive, so I could get 5 over 6, x. Negative divided by negative is a positive, so I'll get a plus. 20 over 6 can reduce to 10 over 3 if I divide 20 by 2 and 6 by 2. So I get 10/3, like that. Not fun to graph. Not fun to graph in slope-intercept form. It would be okay to graph in point-slope form, but I do not know a point on this graph. So I guess, thankfully, I'm not graphing it. So there we go. So this is going to be y equals 5, 6x plus 10/3. All right, finally some problems where you get to do some practice that would be otherwise different. We're rewriting in slope-intercept form each time we're solving for y. So there's that. Oh, here's a point-slope form one. So back to the grind. I guess they'll shuffle it. 1/8 of negative 8 is negative 1. Subtract 4 from negative 1 and get negative 5. So 1/8 x, y equals 1/8 x minus 5. Sorry, I'm still going to kind of blister past those as long as they give me ones like that. This one's a little different, so I'll write it down. 3/2 of negative 8. All right, 3/2 of negative 8. Here we go. So we're going to be doing y minus 4 equals 3/2 times the quantity x minus 8. So I'm going to distribute the 3/2 there, and keep in mind that means you're multiplying 3/2 by x and 3/2 by negative 8. So 3/2 x. Negative 8 divided by 2 is negative 4. Negative 4 times 3 is negative 12. So minus 12. You might be saying, why aren't you multiplying by the top? I don't know. I'm multiplying their second. Negative 8 times 3 is negative 24. Negative 24 divided by 2 is still negative 12. Add 4 to both sides. Negative 12 plus 4 is negative 8. So y equals 3/2 x minus 8. Once again, kind of one of those weird ones that it's like 3/2 x minus 8, 3/2 x minus 8. This time without parentheses, this time without the minus 4. Anyway, that's the final answer. Y equals 3/2 x minus 8. Thank you for challenging me a little bit more than before. IXL, I do appreciate that. I thought you didn't have it in you. I keep getting text. I don't know what they are. It might be a group chat conversation with my softball group. All right, let's see here. This is standard form. I mean, it doesn't really matter. But this is standard form here. We're going to go ahead and get it into slope-intercept form. 16x plus 18y equals negative 17. Again, this would be a very ugly graph. To get y by itself, I have to do 2 steps. First, move the x term over. Subtract 16x from both sides. Now, these two on the right will not combine, as they never have so far. I'm just writing it underneath because I don't have any other room. 18y equals, if I want mx plus b, I want the x term first. So I'll have negative 16x minus 17 like that. And then I divide both sides by 18 here. And any fractions that can reduce, make sure you do so, such as these two evens can divide by 2. So I'll make sure to be doing that. I'm going to be getting myself y equals negative 8 over 9x, and then minus 17 over 8. Can't reduce it. Boo hiss. We'll leave it as is. Leave them as fractions. Even if they're improper, which these are not, you'd leave them as improper fractions. Totally fine. Negative 8/9 x minus 17 over 8. Let's just make sure I didn't make any, 18. Let's make sure I didn't make any mistakes in negatives, positives, and stuff. All good. All right, let's move on to the next one. Maybe at some point I can do this in head. I can do these in my head. I don't want to mess up, but maybe there's some where even you can agree with me that you could even do it in your head when you follow along. Maybe you'd always want to write it down, but maybe every so often if I do it here, just for time's sake, I know I'm at a score of 82, which is pretty close. When I divide by negative, and if I have to reduce fractions, I think I'm going to stick to writing it out. Divide everything by negative 8 to get y by itself, and any sign would change. So instead of positive, it'll become negative, and 6 over 8 reduces to 3/4. So I'll have negative 3/4 x. Negative will turn positive because divide by negative, it has to say plus 7/8 like that. And there's the answer. Y equals negative 3/4 x plus 7/8. A lot of these slope-intercept form ones so far would not be very good to graph, putting it in this form, because it's not about the fraction slope, it's about the y-intercept slope. Even I personally, Mr. Robinson, absolutely hate those fractions when it comes to this. Absolutely, absolutely. All right, let's do this one in our head here. Negative 4x minus 8. Subtract the 4 from the negative 8, you get negative 12. So y equals negative 4x minus 12. Awesome. Yep, definitely want to show the steps here with the 2 steps and the dividing by the negative and everything being a fraction. Wake me up when they're not. Here we go. 12x minus 9y equals negative 20. Subtract 12x from both sides. Don't mind if I do. We'll get negative 9y. Don't forget the negative in front of the 9. Or 9y, please. Negative 12x minus 20. Good. Everything's going to turn positive when I divide everything by a negative 9, a negative 9, and, hey, another negative 9. So we'll get 1y, a positive y, equals negative over negative is positive. 12 over 9. They can divide both by 3. That reduces to 4/3. 4/3 x, negative 20 over negative 9 is positive 20 over 9. Nothing can reduce there, plus 20/9. All right. Y equals 4/3 x plus 20/9. We're doing. Okay. Can we do this one without writing? Let's try it. 7/5 x plus 7/5 of 10. 7/5 of 10. You can do 10 divided by 5 and then take that times 7. 10 divided by 5 is 2. 2 times 7 is 14. All right, 14. So I have 7/5 x plus 14 on the right side. I'm going to add 6 over. With 14, I'll get 20. So I'll get y equals 7/5 x plus 20. Again, worst YouTube video I've made probably before with all this stuff. Definitely wasted efforts. We'll probably do this mentally again. 7/2 x plus 7/2 of 6. 6 divided by 2 is 3. 3 times 7 is 21. Or you can do 6 times 7 is 42. 42 divided by 2 is 21. 7/2 x plus 21. Add 8 to the 21, you get 29. So y equals 7/2 x plus 29. Now, if you're in my class, you'll have to be showing scratch work for this stuff, especially over distance learning, because I need to know how you got the numbers that you did. You have to show your work. Negative 8x minus 64. Distribute the negative 8. Add 1 to negative 64, you get a negative 63. So y equals negative 8x minus 63. Let's hope I didn't make a mistake there. Could have. But I didn't. Okay, let's work on this one. Hey, we're not going to actually get fractions this time. I'm happy about that. More graphable. Negative 12x equals minus 2y minus 20. Okay, we got to get y by itself. It looks like x is about ready to get by itself, but we got to get y by itself. Y equals mx plus b. People might not understand the step from the jump or the logic behind this strategy here. Most people would say, if we want to get y by itself, let's add 20 to both sides. I'm not going to do that. I'm going to add 2y to both sides because I want my y term on the left side. I want my y term positive. Just, give me that much. So I'm going to add 2y here. Meanwhile, I'll just go ahead and add 12x to this side. So moving two things over at once, moving this over to the right, moving this over to the left, moving this over to the left, moving this over to the right. So now I have a 2y on the left, positive, 12x minus 20. There we go. You didn't have to do that, just, seems strategically more viable for me. Divide everything by positive 2, and we'll get y equals, look at this, 6x minus 10. Oh, what a clean looking thing. Ironically, this showed up in the challenge zone. I mean, maybe the steps going there were maybe harder. I don't agree. But hey, challenge me up. I'll take it. All right, because we're dealing with fractions and because 2 steps and all that, let's go ahead and write it down. So 11x minus 4y equals negative 10. This is standard form by and large. You'll notice all these standard form-esque problems, even though some of them aren't exactly. You have no parentheses, you have no fractions to begin with. Okay. Now you might say, hey, will you add 4y and add 10 over to get all positive? Well, because this is already on the left side, I guess not. Whenever I'm in standard form like this with them on the left side, I just kind of follow this protocol. That other one was very uniquely different. Not a lot of problems will show up the way the last one did. Negative 4y equals negative 11x minus 10. Good news is everything will become positive when I divide by that negative 4. And This first fraction cannot reduce, but it will turn positive, like I said. The other one will turn positive, and I can reduce it. It becomes y equals positive 11/4 x plus 5 over 2. 10/4 reduces to 5/2. Try not write these as decimals here. Well, definitely don't in IXL here. They don't want you to, but also not mixed numbers. Yeah, the y-intercept is 2.5. I think I'll have to know that at some point, but just leave it be before you make another mistake when you're working on it. Okay, this is a first. This is good. I want to write this one down. This is one I wanted to actually find before. This is an example of where point slope form is a lot better than slope intercept form when it comes to even writing the equation or graphing from it. See, I don't mind graphing from this because what does this stuff tell you? Let me write it down. What does this tell you? Y minus 2 equals 1/9 times x minus 4. Okay, in fact, I'm going to graph it. What does this one here tell you when it comes to graphing? We pull out the information that we have a point of 4, 2. That's my x1, y1, and my slope is 1/9. So what I can do is I can start from 4 on x, 2 on y, and either rise 1, run 9, which is out of reach here, or I can fall 1, run 9 to the left, like that, and get a new point so it can help me draw my graph. These are the only 2 points I can really fit. But the point is, no pun intended, but the point is here, it's graphable with integer-esque values. Yeah, the slope was a fraction, but no, I don't care because it's all about rise and run. I prefer it as a fraction, really. And there are arrows at the end. Now, why was that good right there and it's better than slope-intercept form? Because in slope-intercept form, this time when I distribute, I'm going to distribute the 1/9 into x, 1/9 into -4, and 1/9 of -4 is not a whole number. It is -4 over 9. Not only is that -4 over 9, but I still have to add this 2 over in a bit. And adding 2 to here with a -4/9 means getting a common denominator or writing it as a mixed number. And no, this does not become -2 and 4/9. You have to subtract 4/9 from 2. So it's 1 5/9, but let's get this with a common denominator and improper fraction. And then I'll tell you again it's 1 5/9. But y equals 1/9 x here. We're doing 2, a -4/9 plus 2 is 2 minus 4/9. And 2 over 1 can be rewritten as 18 over 9, multiply top and bottom by 2. By 9. So by 9 and 9. So I get 18 over 9. If I said 18 over 2, I meant 18 over 9. 18 over 9 minus 4/9, which is 14 over 9. So that'll be 1/9 x plus 14 over 9. Now 14 over 9 is, like I said before, 1 5/9. So that's where you start right here. That's kind of hard to determine and look at, and we had to compute this and deal with the fraction. And then even if you start from there, now you have to go up 1 over 9 from the 5/9 up from 1. Not a fun slope-intercept form problem. I mean, it's fine to calculate as far as practicing. This is one where I would definitely not try and graph at a slope-intercept form. I wouldn't even convert it. Point slope form was absolutely the best one to choose here. I mean, absolutely, without question. Hands down. All right. I still have to answer it. Now I had to still answer this for this. So y equals 1/9 x plus 14/9. I don't even know how to write mixed numbers in this format. I mean, is this going to be 1 4/9? I don't really know. Do I have to put in here, or 1 5/9? I guess I have to put. Do I have to put 1 plus 5/9 like that? I don't even know. So I'm not going to try. They don't give me that stuff. Maybe I'm too zoomed in. Nope. All right, 14/9. Let's zoom back in. I was just thinking maybe I'm too zoomed in and it would pop up like a little, box thingy. All right, this one's easier again. -3x minus 18. Add 5 to -18 and I get -13. So y equals -3x minus 13. Through this entire ordeal of all the problems that I do, I only got one wrong. I'm not done. I'm just saying that's going to be my guess. I only got one wrong through the entire ordeal. I shouldn't have gotten that one wrong either. No. It was a my mistake thing. It was a typing error. Big typo. 15x plus 5y equals -8. Let's get y by itself, subtract 15x from both sides. Looks like I'm going to have some negatives on this other side of the equation. And we'll get 5y equals negative 15x minus 8. Divide by 5. And these are swapped as far as what I'd prefer when it comes to graphing. I don't care if my slope is a fraction. I care that my y-intercept's a fraction. As this becomes y equals negative 3x minus 8 fifths. Minus 8 fifths. Yeah, definitely not a fun one to graph. But an okay one to solve. Okay, let's see if we can kind of do this one in our heads here. I'm going to divide by negative 20 from both sides. Now, the signs will change on the right side of the equation. That negative x will become a positive x over 20, because I'm dividing by the 20. So or 1/20th, really, right? So y is 1/20th x. You could put x over 20, but note your slope is 1/20th. Plus 12 divided by negative 20. Now it'll make it negative, so that's a minus. 12 over 20, they can both divide by 4. 12 over 4 is 3. 20 over 4 is 5. Minus 3/5 like that. All right. Just trying to get something in my head there. 6x minus 30. Add 10 to negative 30, get negative 20. So y equals 6x minus 20. And one more problem here. Oh, 2/7 of negative 7 is negative 2. Right? 1/7 of 7 is negative 1. 2/7 of 7 is negative 2. Subtract 3 from negative 2. I should get negative 5. So I should get y equals 2/7 x. As you can tell, I'm checked out. 2/7 x minus 5. Okay, and with that, well done. Yes, I got 29 out of 30. Boo-hiss. But I got my SmartScore there. And that covers those 4 things. Yes, I did spend an hour 26 minutes doing those ones. I sure hope you learned something out of it. There was a description section below with some timestamps that can get you going. And this is Mr. Robinson, who is mentally drained. Have a great day, guys.